Okay, so solutions of an equation that fall on either the x or y axis, those are called intercepts. Let me get this so it's a little more visible. It's possible for an equation to have one, many, or no intercepts. I'm going to draw an example of each. So for example, a graph, let me draw the axes in blue. So I'm going to draw three different graphs here. That's not a horizontal line, that's a horizontal line. So we got one there, and then there's another one that'll be, I'll have to shift over that in a little bit. Um, let's start this. First one has, let's draw a graph that has only one intercept. How about horizontal line? A horizontal line has one y-intercept. It has no x-intercepts. Let me draw one that has a couple intercepts. So let's draw a parabola, graph of a quadratic. It's got two x-intercepts and one y-intercept. Let's draw an example. Let me shift this. There we go. An example of one that has no x-intercepts. You might recognize the shape. It's the shape we've dealt with in the past. This is called a hyperbola, where both, it's not that good on that one, where both axes are asymptotes. It gets really, really close to the x-axis and the y-axis on both of those curves, but neither curve crosses or touches the x or y-axes. Now, in order to find x and y intercepts, the simplest way is to plug in 0. So to find x intercepts, let y be 0. In other words, plug in y equals 0. And then for y-intercepts, you're going to plug in x equals 0. So let's try out this first one. We're asked to find the x and y-intercepts of the following equations. First one, let's start with the x-intercept. We got x-intercept. So we're going to plug in y equals 0. So we're going to have 0 equals x squared minus 2. In order to solve for the x-intercept, we just got to solve. We got to solve for x. So let's add 2 to both sides. So we have 2 equals x squared. Now, in order for us to get x all by itself, we got to take the square root of both sides. So the square root of x squared is just x. The square root of 2 is not a nice number. It's just the square root of 2. Now, one thing you need to remember, whenever you insert a square root into an equation to solve for the variable, you need to get a positive and a negative output. So that means it could either be positive x could either be positive square root of 2 or negative square root of 2. Remember, you can't take the square root of a negative number, but you can have a negative value after you take the square root. That was a weird way of saying it. Let me try that again. You can't take the square root of a negative number, but you can make it negative after you take the square root. So after we get the square root of 2, we can make it negative. That's perfectly okay. The y-intercept. So that is, this short answer is plus or minus square root of 2 is our x value. The y-intercept, we're going to plug in x equals 0. So we'll have y equals 0 squared minus 2. So we have y equals 0 squared is 0 minus 2, which gives us y equals 0 minus 2, negative 2. So we have 2 x-intercepts and 1 y-intercept. On letter B, let's try the same thing. We have y, let's start with the x-intercept again. So we have 0 equals x to the third minus 4x. Now, looking at this, I don't know where to go. Like, if I add 4x to both sides, then we got to factor. Factoring. We haven't factored yet this semester, so let's try it out. So the first thing I want you to look for, taking a look, let me zoom in a little bit more. Taking a look at the terms we have here. We got x to the third and 4x. They both have something in common. Always look for a greatest common factor. The thing that they have in common is x. So when we factor that out, remember, it's kind of like it's dividing it outward. In this case, it's kind of like undoing the multiplication. The multiplication is still there. We're just breaking it up into multiple pieces. So when we take out an x from x to the third, we end up with x squared. When we factor out an x from minus 4x, we get just minus 4. Okay, so what? We can actually factor some more. Let me shift this a little bit. We got 0 equals x, and then x squared minus 4. You might recognize that as a difference of squares. That'll break down into x plus 2 times x minus 2. That's the difference of squares. Remember, that's the pattern we've looked at in the past, back in like algebra 2 and algebra 1. Probably not geometry, but definitely those previous classes. Now, thinking about this thing, there's something called the zero product property. What that means is we've got three pieces here. We got that piece, that piece, that piece. The product means they're being multiplied by each other. So we have three things, x, x plus 2, x minus 2. They're being multiplied by each other. That means the answer to a multiplication is a product. In this case, the product is 0. So this has a specific property called the zero product property. You'll hear me refer to that throughout the entire semester and probably throughout the entire year. Sometimes I'll abbreviate it as ZPP, zero product property. What that means is we can take each of those pieces separately and set them equal to 0. Because if three things multiplied to equal to 0, one of them has to be equal to 0. So let's set each of them equal to 0. So we got x equals 0, we got x plus 2 equals 0, and x minus 2 equals 0. So we got to take those three pieces and solve for x. Let me do all the work for you in the first one. To solve for x on x equals 0, you're done. To solve for x in x plus 2 equals 0, we're going to subtract 2 from both sides, and we end up with x equals negative 2. We're going to add 2 to both sides of this last one, and we end up with x equals positive 2. I guess we don't need the plus there, just positive. So this one has 3 x-intercepts. Now for the y-intercept, let's plug in x equals 0. So our y-intercept, we'll do y equals 0, in parentheses, to the third, minus 4 times 0. So we have y equals 0 minus 0, which is y equals 0. The y-intercept's right at the origin, which makes sense because we also had another value here at the origin. Okay, let's try one more, and then I'm going to have you do the other three on your own. And you can check out the answer key to check out your work on that one. So let's start with the x-intercept again. So the x-intercept, I missed a letter, x-intercept, we'll do plug in at y equals 0. So we have x minus 0 squared, which is 1. So you have x minus 0 is 1. Well, x minus 0 is just x, so that's x equals 1. That's not so bad. The y-intercept can require a little bit more work. In this case, we'll plug in x equals 0. So we have 0 minus y squared equals 1. Cleaning that up a little bit, let me zoom in on this. 0 minus y squared, that just really means we have negative y squared equals 1. Well, let's get rid of that negative. So let's divide both sides by negative 1. Remember, to get rid of a negative, you can either divide by negative 1 or multiply by negative 1. I usually go with divide. It doesn't really make a difference, though. So we have y squared equals negative 1. To solve for y, we got to take the square root of negative 1, or the square root of both sides. We end up with y equals square root of negative 1. So two numbers we got to think of that multiply to negative 1. You got 1 and 1 is 1. Negative 1 times negative 1 is also 1. You might remember this definition. The square root of negative 1 is this definition I, the imaginary number. So the square root of negative 1 is I. Now because, waiting for, there we go, error server to show that up. Because we put the square root in there, we have plus or minus the square root of I. So what does that mean? What does I stand for? It's an imaginary number. So it's imaginary, so it's not real. So it's not going to show up on our graph. So we're going to say it has no real y-intercepts. Folks, for time's sake, I'm going to have you try the other three on your own. Make sure you're checking out the answer key. Make sure you're checking out your work, compare it to mine, see how you do.